Did you know that natural gas literally heats about half of all the homes in the United States? It is an absolutely massive undertaking to deliver that fuel safely and reliably. Okay, let's dive right into this explainer and unpack the SSAB standards for the gas utilities and distributors industry. If you really want to understand how sustainability and financial risk intersect in the energy sector, you've got to look closely at the precise metrics these companies use to measure their performance. Today, we're going to break down exactly what those metrics look like for the companies piping natural gas right into our neighborhoods and why investors care so deeply about them.
So, when you hear the phrase gas utility, what actually pops into your head? Are you picturing massive cross-country pipelines or just the little meter on the side of your house? It's a genuine question, and your answer completely changes how you assess a company's risk. The energy grid is incredibly complex, right? It's got a lot of moving parts. So before we even try to measure sustainability, we have to draw a very strict boundary around what this specific industry actually is. Because in the vast world of energy extraction and delivery, lumping everything together just leads to a mess of confusion. We need to know exactly who we're evaluating.
Here is our roadmap for today. First, defining gas utilities. Second, the Affordability Balancing Act. Third, promoting end-use efficiency. And fourth, protecting infrastructure integrity.
All right, Section 1, defining gas utilities and drawing that boundary box. We really need to draw a strict boundary around this industry right off the bat. As you can see illustrated here, we are talking specifically about local, low-pressure distribution. This is the final crucial leg of the energy journey. It's all about transferring natural gas, and in some very specific cases, propane, directly to residential, commercial, and industrial end users. And what's the primary purpose of this fuel? It is for heating and cooking. That's the core identity of the gas utilities and distributors industry. It's highly localized, it's heavily regulated, and it's directly connected to your daily life. Crucially, this boundary explicitly excludes those massive high-pressure midstream transmission lines that transport gas over hundreds or thousands of miles. Those belong to a totally different sector, the oil and gas midstream industry, which has a completely different set of regulations and environmental risks. We are also completely excluding electricity provision. Sure, some giant utility holding companies operate in both gas and electric markets, but for these standards, gas and electric are evaluated entirely differently. We are focusing solely on those local, low-pressure gas pipes right under your street.
Okay, moving to Section 2, the Affordability Balancing Act, where we look at managing costs and trust. Making sure utility bills stay affordable, it's not just a nice PR move for a company. It is absolutely crucial for building trust with regulators and customers. Think about their business model. These utilities essentially operate as monopolies in their specific territories. Because of that, their rates are strictly controlled by public utility commissions. If rates get too high and become unaffordable, regulators are going to push back hard, denying the utility the ability to recover costs for new technology or infrastructure. And that regulatory pushback directly hits the utility's financial performance. Affordability is quite literally tied to profitability.
But wow, this gets incredibly complicated for these companies. Utilities have to discuss how external factors, things completely outside their control, impact a customer's ability to pay. I mean, a utility can't control a sudden freezing winter storm that spikes heating demand, right? Nor can they control the underlying economics of their area. If they operate in a region with high poverty rates and lower median household incomes, their risk profile shoots up. They're going to naturally face higher default rates on bills, plus intense political pressure to keep rates artificially low, which really squeezes their margins. Yet they still have to transparently disclose how these external realities impact affordability.
So how do we actually track the fallout from all this? The standards require utilities to report the raw number of residential gas disconnections due to non-payment. But they don't stop there. The really telling metric is what percentage of those disconnected customers get reconnected within 30 days. This gives everyone a crystal clear window into how effectively the utility works with struggling customers. Are they just shutting off the gas and walking away, or are they actively getting that essential heat turned back on through payment plans or local assistance programs? That 30-day window is critical, because going without heat for a month in the winter is a massive health and safety issue.
Let's transition to Section 3, promoting end-use efficiency, or basically, doing more with less.
Now, this sounds completely counterintuitive, doesn't it? A business actively trying to get its customers to consume less of its primary product. But utilities actually sponsor major initiatives. Think appliance rebates, smart thermostat giveaways, home weatherization programs to help customers consume less energy. Why on earth would they do this?
Well, energy efficiency is actually one of the cheapest ways to reduce overall greenhouse gas emissions. Plus, by managing customer demand efficiently, the utility can avoid making massive, expensive upgrades like building larger pipes or new storage facilities. That keeps long-term costs down for everybody. They track this success by measuring the millions of British thermal units, or MMBTUs, of gas saved.
Now, the big question is, how do utilities pull this off without just going bankrupt? Historically, the model was super simple. Sell more gas, make more money. If they convince you to weatherize your house and you buy less gas, their revenues drop, but their fixed cost for maintaining those massive underground pipes stay exactly the same. That is exactly why you see specific policy mechanisms like decoupling. Decoupling is a regulatory tool that literally breaks the link between a utility's profits and its total sales volume. Essentially, regulators guarantee the utility will recover its approved fixed costs regardless of how much gas is actually sold. If it's a warm winter and sales drop, rates might adjust slightly upward to safely maintain the pipes. If it's a freezing winter and sales spike, the utility refunds the excess to customers. It completely removes the financial disincentive to promote efficiency. Companies have to disclose exactly which of these mechanisms are active in their markets because it changes their whole financial risk profile.
Finally, let's jump to Section 4, protecting infrastructure integrity and managing the network safely. When we talk about local gas distribution, we are talking about thousands of miles of pressurized pipes running directly under our streets, schools, and neighborhoods. The stakes here are just incredibly high. The standards strictly define reportable pipeline incidents because investors absolutely need to track safety failures. We're talking about massive, unintended gas losses of 3 million cubic feet or more, significant property damage over $50,000, or, most tragically, a loss of life or severe injury. To put that gas loss into perspective, 3 million cubic feet is enough natural gas to fuel dozens of typical homes for an entire year, leaking out into a neighborhood all at once. Utilities must transparently report these numbers, plus any safety violations they've received.
A catastrophic failure, an explosion, a massive leak. These are the absolute worst-case scenarios for a community and for the company. Aging infrastructure and fugitive methane emissions, which is methane that escapes into the atmosphere unburned, acting as a super potent greenhouse gas, are huge financial, environmental, and reputational liabilities. Which begs the obvious question: how do utilities proactively manage these massive risks before a disaster ever occurs?
To monitor that risk, utilities have to meticulously track and disclose the percentage of their distribution network made from older, riskier materials. Specifically, they measure the physical length of pipes made from cast iron, wrought iron, and unprotected steel. See, historically, cast iron was the standard back in the early to mid-20th century. But those materials are highly susceptible to moisture, corrosion, and cracking as the ground shifts over the decades. Today, the gold standard is modern, high-density plastic piping. It doesn't rust, it's highly flexible, and it has way fewer joints that can leak. Investors look very closely at how much legacy iron and steel is left in the ground to gauge a utility's deferred maintenance backlog, their risk of a leak, and what their future expenses will look like for pipeline replacement.
But look, preventing disasters isn't just about the physical pipe material. Ultimately, it boils down to building a comprehensive culture of safety. The SASB standards require utilities to describe their operational efforts to manage asset integrity holistically. This means looking at the entire life cycle, from the initial pipeline design and how meticulously the trenches are dug, to making sure the welders are rigorously trained, all the way through to daily pressure monitoring, rapid emergency response times, and eventually safe decommissioning. It requires constant, absolute vigilance.
Which leaves us with a massive question to ponder for the future. We've seen how strict the boundaries of these local low-pressure networks are, and how these companies have to constantly balance customer affordability, push for end-use efficiency, and manage the safety of aging underground pipes. As the global energy landscape rapidly shifts toward lower carbon solutions and widespread electrification, the pressure on all these metrics is only going to intensify. Can these local distributors adapt their infrastructure, maybe integrating renewable natural gas or hydrogen, and evolve their business models fast enough to survive? That is the fascinating challenge ahead for this entire industry. Thanks so much for joining me for this explainer.